Think about a busy hospital, maybe an emergency room. A doctor needs a patient's full story, like right now. Their history, labs, scans. Now, the information. It's usually somewhere in the hospital systems. But getting all those different systems to talk to each other and then feeding that instantly to an AI, that's the real challenge nobody talks about.
Yeah.
Healthcare runs on this kind of patchwork quilt of data standards. Patient records here, imaging there. It makes it incredibly tough for the latest AI to actually get its hands on the real-time clinical data it needs to, make a difference. So today, we're doing a deep dive into a potential solution, something that's being called a universal port for AI in healthcare. Could really change how fast AI tools get into clinics.
Yeah, you've nailed what we often call the integration challenge. It's been the reality for decades. Every time you want to add a new AI feature or some smart tool, you end up needing to build this custom glue code. Yeah, basically bespoke software, a unique hand-built bridge just for that one connection. For every single feature, every single time. And you can imagine, right? That means super slow release cycles for new tools, loads of duplicated effort, engineers doing the same kind of work over and over, and it's a nightmare for compliance, for audits. Honestly, hospitals are demanding faster, smarter clinical tools now in this old way. It's unsustainable.
Exactly. Which brings us to what we're exploring today, the Model Context Protocol, MCP. It was unveiled by Anthropic, and it's an open protocol. The whole idea is to tackle these exact connectivity problems head-on. To really get why MCP is a big deal, you need a picture of just how messy a hospital's IT setup can be. It's fragmented, different departments, even different machines are basically speaking different digital languages. You've got FHIR, that's the newer standard for patient records.
Right. FHIR is becoming key.
Then there's HL7. That's more for messaging, like lab results going to a doctor. DICOM handles all the complex medical images, x-rays, MRIs, you name it. And then, layered on top, you still have old-school SQL databases, maybe even ancient CSV file exports floating around.
It's a real mix.
Yeah, it's like trying to plug a modern game console into an old TV without the right adapter. Every new AI feature has needed its own custom-built connection into this tangle.
And the results of that kind of brittle integration, they're significant. Innovation just moves at a crawl. Good ideas get stuck in that basic integration phase for ages. There's just a huge amount of wasted engineering time, basically reinventing the wheel constantly.
Right. The same connections again and again.
Exactly. And compliance. Trying to keep data secure and private across all those different custom links, it's incredibly difficult. Think about, a doctor waiting for insights that are held up for months just because of integration hurdles, or administrators trying to make things run smoother. The current setup really holds back progress.
Okay, so enter MCP, the proposed fix. People are calling it the USB-C port for AI. I think that's a pretty good way to think about it. You know how USB-C works? You plug in pretty much anything, phone, monitor, hard drive, and the computer just figures it out. No special drivers needed usually.
Auto detection.
That's the dream for MCP.
Yeah.
A standard way for these large language models, LLMs, to connect to basically any hospital system. But, okay, let's unpack that. How does it actually work? What are the bits inside that make this universal port concept possible?
It's a solid analogy because it highlights that simplicity and power. MCP boils down to three core parts, or primitives as they call them. First, you have tools. Think of these as commands or action endpoints. Things like create patient summary or maybe schedule follow-up. The key thing here is action. These let the AI right back into systems, do things.
Okay, so not just reading data, but actually performing tasks.
Exactly. Then second, there are resources. These are more like read-only data fetchers. So get patient context or formulary lookup, checking which drugs are approved. These are crucial for getting that fresh, up-to-the-minute clinical information.
Got it. Read versus write.
And the third piece is prompt templates. These are like pre-built instruction guides or scaffolds. They help make sure the LLM's output is consistent and high quality, like using a standard template for all discharge summaries. What's really neat is how these three things work together. They allow the AI to interact, dynamically understand the situation, and take appropriate action.
It's not just about standardizing the pieces, right? You mentioned something called dynamic discovery. What's that about?
Yes, that's really clever. Instead of a developer needing to manually code every single connection or capability the AI might need, an MCP client, the AI side, can just ask the system, hey, what can you do?
Like a query.
Exactly. And the system responds with a machine-readable list, a catalog of all the tools, resources, and templates it offers. This means it can adapt on the fly when new services or capabilities are added to the hospital system, often without needing a developer to step in and rewrite code.
Wow, okay. So the system becomes sort of self-describing to the AI,
Precisely. And the communication itself, it's done using lightweight JSON RPC.
which is just a standard way for programs to talk online, right?
Yeah, pretty common, simple. It keeps things efficient, auditable. You can log every call without needing bulky, complex middleware software in between.
Okay, so we've laid out the problem, this complex patchwork system and MCP as the potential solution, this universal port idea. But let's bring it back to the people involved. What does this actually mean for, say, hospital leaders, IT folks, maybe even clinicians? Why should you care about MCP? What are the real tangible upsides here?
Well, if you look at the bigger picture, MCP really could change the game in terms of speed, security, and just the sheer flexibility of adopting AI in hospitals. There are, I'd say, 4 main reasons it's important. First, accelerated innovation. We talked about the bottlenecks. MCP aims to remove them. This could mean new AI workflows spinning up in potentially days instead of months. Think about getting useful tools out there faster.
Days versus months is a huge difference.
It really is. Second, simplified compliance. This is a big one. If you run an MCP server on premises within the hospital's own network, it can inherit all the existing security controls, HIPAA, HITRUST, HACI2, whatever the hospital already uses and trusts. Audits become much more straightforward.
Okay, so leveraging existing security infrastructure.
Exactly. Third, vendor neutrality. This gives hospitals flexibility. With MCP as the standard interface, you could potentially swap out the underlying AI model, maybe switch from Claude to GPT, or use an open source model without needing to rebuild that whole integration layer from scratch.
That avoids vendor lock-in, saves a lot of potential rework.
Huge cost and time savings, potentially. And finally, number 4 is reduced engineering overhead. Instead of building connector after connector, a single MCP server can act as the gateway, exposing multiple hospital systems through that one standard interface. It just drastically cuts down on that repetitive, duplicate integration work. It's a major efficiency boost.
That all sounds fantastic in theory. But how does it look in practice? Are companies actually doing this? You mentioned Cabot Solutions implementing MCP. They describe it as a nimble extension, which sounds important, not a rip and replace.
Right, that's key. Hospitals can't just pause operations to overhaul their IT. It has to be additive.
And Cabot is apparently offering things like reusable prompt templates, toolkits to get started quickly, and importantly, compliance guardrails built in, making sure data stays IPA secure.
Absolutely. Let's make it even more concrete. Imagine setting up a HIPAA-compliant MCT stack. A really potent combination right now is using Anthropic's Claude 3 model via Amazon Bedrock.
Why Amazon Bedrock specifically?
Well, Amazon Bedrock is part of AWS, and it's explicitly designated as AKA eligible under AWS's Standard Business Associate Addendum, the BAA. This is crucial because it gives healthcare organizations the legal and technical assurance they need to process protected health information, PHI, using these powerful AI models, but within a secure AWS environment. The data doesn't leave that controlled space.
Okay, so the BAA is the key piece there for PHI.
It is. And beyond that, Bedrock has strong security features baked in. Data is encrypted when it's moving and when it's stored. Hospitals can even use their own encryption keys for extra control. Plus, it operates under the same stringent compliance frameworks, ISO, SOC, FedRAMP, that hospitals already rely on for their core systems, like electronic health records. So there's existing trust there.
Okay, so you have the secure platform. How do you actually deploy the MCP stack on it? What are the steps?
It's a process designed around security, step by step. First, you'd containerize your MCP server. This means packaging the MCP application, maybe built with something lightweight like FastAPI, into a container. You'd then run this container in a private part of your AWS cloud, like EKS or ECS, which manage containers for you.
Private being the operative word.
Absolutely. Second step is secure connectivity. You don't want this talking over the public internet. You use AWS features like VPC endpoints and a private link to create a secure, private connection directly between your MCP server and Amazon Bedrock. No public exposure.
Got it. Keep it internal.
Third, you need to enforce minimum necessary. This is a core HIPAA principle. Only use the minimum data needed for the task. So any patient data, like FHIR bundles maybe, coming into the MCP server gets routed through a small, dedicated microservice first. This service strips out or tokenizes personal identifiers, names, IDs, before the data even gets sent to the Claude model in Bedrock.
Ah, so the AI model itself doesn't see the raw personal data if it doesn't need to?
Precisely. Fourth, immutable audit trail. Compliance demands proof. You use AWS logging services, CloudWatch and CloudTrail, to automatically record every single call made to the MCP server and every interaction with the AI model. Creates a permanent, unchangeable log.
Okay, traceability is covered.
And fifth, maybe the most important step for clinical use, human oversight. Any outputs from the AI that are meant to go back into clinical systems, like a draft summary or a suggested action, don't go directly. They're first sent to a secure queue, something like AWS SQS. From there, they can be reviewed and approved by a clinician before anything gets written back into the official patient record, the EHR.
The human in the loop. Critical for safety.
Absolutely critical. So you put all those pieces together, and what you get are AI agents that are scalable, genuinely HIPAA compliant, and can start delivering valuable clinical insights much faster, all without adding risky new vendor integrations or compromising patient data security.
So wrapping this up then, the model context protocol really emerges as this potential key piece, this bridge, a bridge between all those isolated, siloed hospital systems we talked about and the full power of what modern AI can do. By standardizing how systems are discovered, how they're governed, how they communicate, MCP seems poised to turn that collection of disconnected apps into something more like a coordinated, auditable AI ecosystem. It really could pave the way for AI in healthcare to move from just being a promising idea to being a seamless, integrated part of daily clinical reality.
And that really brings up an interesting final thought for you, our listener, to chew on. If a standard, a universal port like MCP, can potentially unlock so much value in a complex field like healthcare by accessing tricky data and enabling safe AI, where else might such a unifying standard be transformative? What other industries, maybe ones completely outside of tech, are wrestling with similar integration challenges and could benefit dramatically from their own version of a universal protocol?